Hi everyone, time for the next video about motion and forces. So today we're talking about three important forces, and they are friction, which is the force that opposes motion, gravity, which is the force of attraction between objects, and magnets, which are a pretty unique type of force. So we're going to start out with friction. You can see here friction is the force that opposes motion. And how it works is that every object, no matter how smooth it looks, is rough. And there are tiny little hills and valleys in these objects that are sticking to the tiny hills and valleys in other objects, and that's making them slow down. So friction is usually the force that is causing something to slow down, or there's so much friction that the object isn't even moving at all. Here's an example of a difference between friction on two objects. So the grass has higher friction because it's a lot rougher than the smooth surface here. So the ball will move faster and move for longer on the flatter surface, but that doesn't mean there's no friction at all. There's still friction here, it's just lower. So a lot of times in real life, we want to reduce friction as much as possible because it causes things to move slower, it can make things hard to run, and so some things that we use to do that are motor oil, waxes, grease, all things that the Tin Man loves. Okay, second force, gravity. Gravity is the force of attraction between two objects, and it depends on two things. The first thing is mass, and the second thing is distance. These are the two really important things when it comes to gravity. All right, here's a picture from Brain Pop that's showing you that because the Earth has a much bigger mass than the human, it has a lot more gravity than the person does, which makes sense. That's why we don't float off of the Earth, because we are attracted to the Earth. It's a gravitational pull. Here's a cool diagram that explains why our planets are all orbiting the sun. The sun has a huge mass, 99.8% of the whole solar system. Here's the planets to scale. And so this is why all of our planets are moving around the sun, even though some of the planets are so far away. The gravitational pull of the sun is so strong that it doesn't matter. It still causes the planets to move with the sun. Super strong, strongest star close to us. So the reason why in space astronauts have no or low gravity is because they're far away from Earth's gravitational pull. So that means that there's less gravity happening. Important that the gravity of the Earth is always the same. It's always a force of 9.8 newtons, but the distance causes the effects of gravity to change as you move further away. If this astronaut moved closer to, let's say, the moon, she could get sucked into the moon's gravitational pull also. Okay, magnets. Magnets are things that you probably have heard of before, maybe even played with. They have two poles, a north and a south pole, always, every magnet. Every magnet also has this magnetic field. It's kind of like a force field that is its kind of area of reach. That's called magnetic field. So on magnets, opposites always attract, and the same poles will repel. You might have experienced this before if you tried to put two magnets close to each other and they won't touch. That's just because it's the same pole, so they will not be attracted to each other. Real life example of a magnet is a compass. You probably have one on your phone if you have a smartphone. Compasses use the Earth's magnetic pole and the Earth's magnetic poles, which you might not have known that Earth has magnetic poles, to tell direction. So these lines that are going around the Earth here are showing you the magnetic pole. Also interesting that the south pole of the magnet of Earth is different than the geographic south pole, and that's same true of the North Pole also. All right, thanks for watching. Don't forget to do your discussion post, and I will see you again next week. Bye.